But if I didn't have these correlation names in here and I said vendor ID, well, vendor ID, you figure it out. And say that's yeah, we got a little. Yeah, and that's right. We would, if you have a, we filter that out. If the invoice total is still greater than what you paid up, if the balance
Excuse me.
Yeah.
So when we run this query, would we get would we get the rows wherein we have common vendor ID on both the tables?
I'm sorry.
When we run this query, would we get the result to be, will the result contain only those records which are having common vendor ID? That is, should they match from both the tables?
Oh, let's see if I can pull this off. And let me go back to here, and let's do a new query. And I'm in the AP database. Oh, let's see if I didn't do anything funny with that. Okay, that vendor name, invoice number, okay, balance due as joint, okay, got that. Invoice, that looks pretty good.
It won't like your dashes.
It won't like the dashes, you need commas.
Or you change your dashes to real dashes.
Okay, so I got real dashes in there, but it's not the one they want.
Yeah, it's not the thing.
All right, so no, I can't put commas in there. This is subtraction. Okay. Okay, they must have another. That's why I had that strange font there. That stuff that makes it look like I wrote it in there and I didn't.
So which one are you using? That was it on the number pad?
Pardon?
Minus on the number pad?
Yeah, that's what I did. Make sure I got that. This one was okay. I don't know how that got in there. All right. Let me do something here. Options. Okay. Fonts and colors. Oh, I think we can get 18 out of that. Sort of. Yeah, that's better. I, give up on the tree structure there when I need it. All right, so and then we'll execute it. All right. So I got 40 rows out of that 140 invoices or something like that. So all it's going to give me is vendor names, an invoice number, and if you got a balance due. Everything else, there's some that are already paid up in there. Okay. Got it? Yes, sir.
I'm sorry, to sidetrack you, but I can't get my AP database to load. I can't attach it.
I'd have to look at that a little bit later. I don't know. You shouldn't have a problem attaching it. You just got to make sure you got it on the C drive.
It's on my desktop, but you said you can't find it.
Yes. Put it on the C drive. Just move it to the C drive, and then that'll clear it up for you. Okay. A desktop is a little strange. It's not I don't call that real space. Okay. All right. Any questions on that? What's more important, not the this process right here. This is what's going to keep you from going astray, and the database diagram. Okay. All right, let's get on with some more particulars here. Okay, this is just a suggestion. Well, it's not a suggestion, you're going to have to do it, because quite often is that the way that foreign keys are created, they're just going to use the same name as the primary key in the parent table. And so when they do that, then you've got to have these correlation names. And when you start working with 4, 5, 6 tables, which is not uncommon, more than that, correlation names are going to make a lot of difference. In fact, there's probably some standards in some of the shops that says, when you have queries that large, identify all of your items with a correlation name. And that includes even in the select list, so I can see where those things came from if I've got to read something that you did. Okay. Questions on that? There is, we got plenty of time. Okay. All right. Okay. List the vendor name, city and state where we have at least 2 vendors in the same city. Okay. Let's think about that a minute. So I've got vendor name, city, and state. Heck, the only thing I got is one table, don't I? Just one table. Okay. Vendors. So I got one table. Okay, just think of it. I got the vendor name. Is that what we're asking for? Yeah. City. And state. I guess one thing we could do, and we got 1, 2, 3, 4, 5. I can start here. Okay, and I can go down record by record and see if there's another record in here that has the city that's the same as this one I'm looking at. My daytime computer science programming students could give that to them. That's a good problem for them. We could do that. And then we could, okay, got that one checked off. If I found one, I'd mark it and say we're gonna include it. Candidate. And then I'd go to the next one and do that. You got the idea. See, there's a lot of enthusiasm for that approach. Or maybe what we could do is if we had 2 copies of the same thing. 2 copies of the same table. Well, if I had vendors here, and I had, so I had vendors. I might call this table B1, and I had vendors. Now I might call that table B2. And then if I do a join, okay, well what would I join on? Vendor name. I join on vendor name. Join on vendor name. then what would we do? Filter out where the cities on each one of them are the same. And the state is the same. Do that with a nice, simple declarative query. What's known as a self-join. A self-join. What we do is we actually create, we always have to have two tables to join. But in this case, it's the same table. Okay. And then what we do is if we do every combination of, that's what a join does, it does every combination. It says, I'll join this one with every one of this, I'll join this one with every one of this, I'll join this one with every one of this. We'll filter out, okay, or select those where the cities match. But also, don't forget, I'll be joining with myself over here someplace. I don't want to include that, so I take that one out. So, this is the notion of a self-join. Okay? Okay, we join a table with itself. Okay? And another key point here is two tables are required for a join. Okay? And again, we have to use those correlation names now because then both of them look alike. So I've got the little correlation names. And I must qualify each column in the correlation. Because I've got to say which city and which table are you talking about. Okay? And now, here's what that would look like. Okay? Let's see if we can follow along with just the discussion we have. All right, I got to have vendor name. Okay, that's all I want to see. I just want to see a list. The vendors, remember the vendors were in the name and city and the state. From the vendors table, B1 join the vendors table. So the compiler says, I don't have any problem with that, I'll just make a copy of it. In fact, it makes a copy of your table anyway, so you've got two copies in memory of the table that's stored out there. So the criteria is, the one we're looking at now is the cities the same, and is the states the same, and it's not the same vendor. And we've got to go by the ID. Because remember what we're going to do here is when we do a join, basically, it's like cross multiplication. I'm going to take this one, I'm going to join it with all the records in here. I'm going to take this one, I'm going to join it with all the records in here. I'm going to take this one, I'm going to join it with all the records in here. So if we've got 20 rows in there, okay, 20 times 20. 400 rows in our final output. Not quite what we want. So we want to filter out when they're the same, but we want to filter out when I cross with myself, because we're not going to count that. Okay. Okay. And then we'll order by, okay. And then we'll
Why do you need the word distinct?
don't need it there because the vendor name is going to be distinct. I'm going to take that out. But remember, the query was, in what cities do I have more than one vendor, or two or more vendors? And so in that case, it would show up multiple times, and I only want to see the name listed once. What we'll do is we'll go ahead and we'll run it like that, because for some reason I wanted to see something, and I don't know what I wanted to see, but let's go find out what it was. Okay. And then we'll answer the question like it was asked. Okay. All right. And I'm going to go ahead. I'm going to swipe this. All right. Oh. Uh-oh. the undo. It's got some sticky goo on it. I don't know what I'll do. Get smart. All right, so I'm going to go back out here. I'm going to just do a new query. Okay. All right, let's see, what have I got? Well, okay, it doesn't like, some, will,
I think this was the previous one.
I got the previous one, what's going on? All right, back up. What did I do? I didn't do did I do a copy? All right, let's see if I got that. You know what? Where did I get that negative sign? I don't have anything like that. All right.
I think you still have the one copy from the previous.
Yeah. Better. Okay. Yeah, probably. Okay, let's do that. So everything looks good. All right, let's see if we get the results we're expecting. Okay. Okay, so I don't need the distinct here, and I've got 84 rows. Okay, I'm going to take the distinct out and the name out, because all it was asking for was where I had vendors and two or more vendors in the same city. Okay, so and if I take, well, let's take the vendor name out. I'll just take the vendor name out. Okay, and let's see if I can do that. It may not like me to do that or not. Let's see if it does. What it would do now is I would see Phoenix, Arizona, California, Anaheim, Fresno. That probably wouldn't make a nice report. You repeated yourself. So you just wanted to say, I don't care how many vendors were in there, I just want to see what cities we had at least 2 or more. That's all. Okay, so I'm going to execute that. Okay, so this would have been your report. You said, boy, that's crummy. Right? Just, get to the heart of the matter. Yeah. All right. So what you'd say is, okay, I know what I need to do. I need to get rid of the multiple copies of those rows in the result set. So you take out the what? Oh, I'll take it out. Okay. Yeah, I took it out all right. All right, let's go back. Undo. Where's my undo?
Control Z.
All right. Shortcut. Thank you.
Keep going.
I got to do it. They only do it one at a time. Okay. All right. Now, let's execute. Okay, that's more like what we had in mind. 15 cities. Okay. Questions on that? Self-join. What it is. We needed information from only one table, but in order to get that information, we needed 2 copies of the table. And so that's what's referred. We create a self-join. It automatically makes the 2 copies for us. The bottom line is that everything has to be used with a correlation method. Okay. Any other questions?
Instead of the vendor ID, the last condition V1 dot vendor ID, can't we use V1? Yeah, can't we use v1 dot vendor name not equal to v2 dot vendor name?
That's pretty dangerous because I may not have it. It turns out that I think probably in this one it would be okay, but I might have two vendors with the same name, but they're a different vendor. Okay, so it's better to stick with the numerics.
So whichever is unique, I mean vendor.
Yeah, right. And that's the primary key. I'd stick with that. Okay.
How does it know how to order the cities alphabetically?
I did the order by state,
Oh, yeah.
order by city. I did state first. You know, if you see the state and then the cities, I did by
Oh, I know
state,
what my question
by
is.
city.
Before, when you had the name in there, it ordered the vendor name. How did it know to do that?
I
Had
don't
an
think.
alphabetical order.
It couldn't have. I don't think it was in alphabetical order. Yeah. That might have been just coincidental.
Because it had like Phoenix, and then it had AT&T, Computer Library, and Wells Fargo.
It may have just, it may have been the way they set the table up and the order in which they put those in.
Goes back to that one, where you see all states are
The city names.
So, you have to remember, they don't have too many names in any of those states.
but then you
so.
go to CA, and it's a different region. Yeah, I know that. Until you get the Aztec version.
Yeah, but then that's the different cities.
Yeah, might be
Do you
different.
have the AP on your C drive?
Yes.
Okay, database, here this one, right click,
All right,
attach.
let's look at another one. Now this one's going to be a real multi-table query. I'm going to generate a report that shows the vendor name. I'd like to have the vendor name, invoice number, invoice date, line item amount, general ledger account description, line item chart. Wow. Okay, back to our approach. What is it do I want? It's going to go down the left-hand side here. So they want a vendor name. So we're going to be a vendor name, and what do we want? An invoice number, and we want an invoice date, I'm going to do this now. Invoice date. Line item amount. Line item amount, MT, that's going to be good enough. The GL account description. GLA descript. My shorthand for that one. Anything else we need? For all invoices that have an outstanding balance. Uh-oh. So that's going to mean, okay, golly, we're going to have a balance, okay? And we know we got to get a balance, we know we're going to have the invoice total, okay? The payment, we got to have that. We're not going to display it, but we're going to need to have it. Payment and the credit. Okay. One table, two, at least have enough. We don't know how many we're going to have. All right, so now we go to the database diagram. And that's what's going to help us with that. I'm going to go back. Where's my diagram? Over here, diagram. So now I'm going to look at my diagram. Okay, let's do the vendor thing here first. So Do I have anything with vendor name? Yeah. So it looks like to me I'm going to need to probably have a vendor table. I'm going to need that table. Get that information. Typically what you can, if a database is well designed, something like a name or something is only going to appear in one place. You're not going to repeat that. The only thing that gets repeated somewhere is going to be a primary key that's treated as a foreign key. Okay, that's the only legitimate thing. Now we see all this invoice stuff, so let's go to the invoices. Okay. Table. And let's see what we can get out of this one while we're, yeah, this is a critical table here. I've got an invoice number, okay, so I need that. Invoice date. Okay, there's no line item stuff in there. Okay, the payment date. Oh, not that. What else do I need? Oh, here we are. These right here. We're going to need those three items, okay? So we knew that was going to be in there. We knew that was going to be in there. Uh-oh. Very away. You guys are letting me get away with stuff. Points. Invoice. B-O-I-C-E. So invoice number, invoice date. Okay. Invoice total, payment, and credit, and the balance is calculated. What else are we asking for? Line item amount. Line item amount. There's something in here.
Yeah,
Yeah.
Okay, invoice line items. Okay, so I'm going to need that table. Invoice. Line item. And I'm going to get that out of there. And the GLA description, the general ledger description. Okay, so that's in the GL accounts. Okay, so I got that to deal with. All right, so now I got that one, GL accounts. All right. In order to do our query, we're going to have to join all four of those tables together. And we got to join them on the primary foreign key pairings. So if we're looking at the vendor table, okay, we'll start at the top. Well, we'll work from the invoices. Okay, invoices looks like what I might call the key table here, but I need to get the invoice, so I've got this primary vendor ID is going to be a join criteria. And we needed to get from invoices to invoice line items. Okay, and so it looks like the invoice ID, okay, here's the primary key, here's the foreign key. Okay, so we're going to link these two tables with this pairing here. And then in terms of this account here, be the account number. So we got an account number in here, okay? Okay, it's going to be, and it's not really a foreign key, but it's at least an identifier because we have an account number there. Okay. Does everybody follow what we did here? Okay. As soon as you lay everything out like this, then you can see where I need to make. I can only make the connections along these lines. If it was well designed, because all funny that it's different. All right. Everybody kind of got the picture. Let's see what the query might look like. That should match what we've been thinking about here. So let's look at that. And we'll do that one. Okay, wow. Now it's starting to get pretty ugly. But we laid things out so we can see things. So first of all, you know, the join is the thing that takes place. So it's going to join vendors and invoices on the vendor ID. That's what we saw. We now have an intermediate table of those two. We're going to join that table with the invoices line items table. Okay. And then we'll have another intermediate table, and then we're going to join that one with the general ledger table. I don't have board space. I want to illustrate that here. I'm going to take. We've got all this. Okay, we're not going to need this anymore. That just helps us decide. You know, we did all this just to decide what that is. Okay. All right. You know, we kind of got ourselves a check here. All right. So now I'm going to take that out. Now I'm going to kind of draw these little tables of just how I'm doing the joins. Okay. So first of all, I'm gonna do a kind of a symbolic thing here, but join the invoices, vendors, and invoices. And we join on vendor ID. ID. Okay. And I get an intermediate table. Okay. That's the result of that join. Okay. And so it includes all of the information for invoices, all the information from vendors. Except it really doesn't, because the compiler is going to go and look at that select list that we've created. It says stuff that I don't need, it's not going to include that. So it's going to make those tables kind of skinny before they do the join. Okay. So I got an intermediate table here. Okay. And then I'm going to join that with the invoice line items. Okay. So now I got invoice line items. Invoice line items. And we're going to join those on what? Invoice number. Number. Okay. Invoice line items, join on invoice ID. We'll call ID. So we'll stick with that. ID. Okay, invoice ID. Okay, so now I've got another table. That's the result of this and this, which is the result of the two previous. Okay, you just keep accumulating. Okay, so I got another intermediate table, and then finally I'm going to join that one on with the general ledger, GL, and we're going to join on that one with the account number. Account. Now, what we have is one table with the essential things that we need. Okay. And it's already selected out the columns. So all we need to do is filter out, calculate the balance due, and filter it out. So only those where we have a balance due. So then it takes out all the rows that we don't need, and we keep that. And then we'll go ahead and order it by the vendor name and a line item amount in descending order. Not sure why we did that. Descending. Go from Z to A. Might have been the line item amount a bit better. Oh no, I'm sorry, that's not right. It's associated with that, not the whole thing. So we're gonna We're gonna show the high to low, okay? All right. Everybody follow what I did? Yes, no?
Yes.
All right. Okay, this is when they get fun. All right, Control C. I got some minus signs in here, but those are pseudo minus signs. I'm going to do a new query. Okay, yeah, it doesn't like those things. How I got those in there. Delete that out. I'll do that one. And I'm going to take that one out. Delete. Good thing I had all these in here. Boy, that's a pretty good query. All right, and then we'll execute it. So, syntax near line 12. Well, let's see. Where am I at? Okay. Line 12.
I think we got another red pseudo negative
Very
in the
bottom,
end,
pseudo.
in the bottom.
Oh, I got something down here. Thank you. Your eyes are better than mine. Delete that. I'll get that down there. All right. Okay, success. Okay. So we went from line item amount. I didn't order that right. Line item amount. Descending. Vendor name. Oh, what's going on there? That should have went from high to low there.
It does by vendor name.
Yeah,
Yeah.
it has to stay with the name, the amount.
Oh, it's doing that. Gotcha. I'd have to list that one first in order to get.
I don't think you can have your kids know what it is.
Pardon?
You can't have both. You can't have alphabetical order and then also by the line item.
Well, it's not necessarily by alphabetical order.
Vendors' names are.
Yeah, I know that. Well, let's do this. I'm curious now. Ruby. Oh, I can't do that. It won't make any sense, will it? All right. Yeah.
Can you put descending with the vendor?
Well,
I mean, the way it was.
well, no, it was. This wouldn't, the line item amount, well, no, that's right. It would do that. What it does is, I'm just going by the highest line item and then the vendor would go with it. Yeah, this is gonna be all right. Let's do that. All right. Yeah, this is good. Sure. Just that the vendors aren't together necessarily. Since we got, they're the culprits right there.
They're
United-
expensive.
UPS, okay? They're way up there. All right. Any questions? Okay. The key point that made this, essentially a piece of cake was create that table we did. You do that, life will be a lot easier.
Let's work out a schematic for you.
Pardon?
Let's work out a schematic for you.
Yeah, you call that what you call a schematic for table. Board sketching. Okay? That way you. All right. Let's, okay, so that was multi-table joins, And it's not uncommon to have 5 and 6 table joins. I've worked with things where maybe it was 12, 13 tables. I don't think I'm anything larger than that, but still, that's quite a bit. I pasted it in at work. Well, yeah, I know, it's kind of, yeah, if you're copying off the PowerPoints, don't forget, it has its own, yeah, it's got a lot of its own funny stuff in there, and I'm thinking, you know, so far I haven't gotten dinged too badly, because we just had the what looked like negative signs, they weren't.
M dash or N
Yeah,
dash?
dash or something funny. Okay, show me the vendors who currently do not have any invoices. If I look at the database diagram, where's my diagram? Oh, my diagram's getting. Oh, we're not going to need these. I'm going to close some of these things. So I need to, no. Okay, there's my diagram. So if I look at my database diagram, all I have is invoices. And I got the vendor ID, but if you don't have any invoices, you're not going to be in that table. If you don't have any invoices, you're not going to be in that table. So what we have, let's look at okay, so we'll do the brute force computer science approach first, because we're not going to do that. So I got all my vendors over here. Vendors. Over here is all my invoices. So I can start with him. Do a lookup in here. Do you have anything in there? Yes or no? If you don't, hey, you're good. You don't have any invoices. Go to the next one. Do the same thing. If you have an invoice, well, I'm not interested in you. I'm only interested if you don't have an invoice. Does everybody see what we're doing? To do it, brute force. But, you know, we don't want to do that. We want to do something slicker, nicer. That's a bit easy. Okay. That introduces us to this notion of an outer join. Okay. And then we'll see we've even got something better. But we'll do the outer join because somebody always wants to know about outer join. And so we're going to do it. Okay. So, back to here. Outer join. Okay. Let's look at the syntax, then we'll say, what is it going to do for me? Okay, it looks just like a join. What we've been talking about is something referred to as inner join. We match on common columns. Okay. So I'm going to do that here. So I'm going to have diagram here. So here I got one table, and then here I have another table. And I'm just gonna call it table A, we're gonna call it table B. And the only requirement is that we have common columns in both tables that have common values. Now typically when we do that for databases, that's going to be a primary key. And we'll stick with that because we don't need to do the math stuff, but, and a foreign key. Okay. That's going to be our practical thing. Okay. So what we have is when we do an inner join, we're looking for a match. I should have if I've got a well-designed database, my primary key has some listings of, reverse that. My foreign key in here will have a key that matches in here. And so when I do the join, then if this was a match to this one right here, then we would join those two together because that information is related. That's where you get this relational database. Okay? They're related. They belong together. You know, if this was a vendor, he has an invoice over there. It's his invoice. But this is what's referred to as sometimes a parent or independent table. This is referred to as the child table or dependent. In other words, no records in here can exist unless I have a record in here. But I can have records in here, say this one and this one, but I don't have any matching ones over there. What I'd like to do is, what are these? That's what the outer join is going to tell me. It's going to help us get to these. Or I can use the computer science approach, which I didn't see a lot of detail in that. All right, so we're going to join these two tables, not on the basis of equality. It's going to be either what's referred to as a left or right join, and I'm going to explain each one of those on a condition. Okay? And we can have as many of those as we like. We're just going to stick with two right now. Left outer join. So if we want to have a left outer join, we put in the keyword left join and the join condition. And generally the join condition is going to be a primary foreign key pairing because that's the way these things are connected. Okay, here's the way it works. Let me put a little simple example up here. So I think I've I'm going to go back. Let's suppose I had, very, very simple. I got, okay, so I've got table A, and I've got an ID here. It's an ID. 1, 2, 3, 4, 5, 6. Simple. And over here, I've got table B. It only has 4 records in it. This is a primary key here. This is a foreign key here. And I have 2, 3, 5, and 6. rows that match in the join condition are added to the result set. Okay, so here I'm going to have a result set of the join. And we'll just have a, let's call this, I'm going to, sorry, do this right here. And I'll have a column X there and column Y there, and then we'll have the ID. I got to have a pseudo column there. Stuff. So I'm going to join these two tables, and we'll have the ID. Okay. So I get a join on 2 and 2. Okay. So we'll have 2 and have the X information. We got the Y information. Okay. And okay, we got 3. So we got 3. And we got, you know, X and Y information. We got 5. Okay, so we got 5, and we got the X and Y information. And then we've got 6. Okay, we've got 6, X and Y information. Okay, all rows. Okay, the first one is all rows that match in the join condition are added to the result set. Okay, we got that. That's number 1 up there. Okay, all rows from the left are preserved table. Okay, this is the left table right here, left. Left table. On the left. We want to preserve all of the rows in there. Okay, so we'll say all the rows from the left preserved table that do not match, which is 1 and 4, are also added to the result set. So we're going to add these in. 1 and 4. Okay. We're going to add those. Okay. So we have some X information in here for those. Yeah, right here. X, X. We have no Y information because it's nothing over there. Okay. Okay. The column values from the right are non-preserved table. That's their terminology. For the rows that do not match, we'll add nulls. So there will be a N-U-L-L, N-U-L-L, no. Okay, now, you got a clue as to where we're going to find the ones that don't have invoices. The ones that have null values in that column. So now our query will be a vendor name, invoice number. Okay. If you don't have an invoice, guess what? You don't have an invoice number. Vendor B, left join invoices on vendor ID. Okay, let's take a look. And then we'll expand on this. Oh, I guess I'll just... Ah, I got a bunch that don't have invoices. Okay, there's an invoice number there. We got scads of them up front. Okay, there's a bunch. I got 262 rows of invoices. Okay. All right. this would be just a little more sophisticated, what would I do? Give me the ones, filter out the ones that have no in the invoice ID table, and that would be a list of the vendors who don't have any invoice. Let's see if I did that. If not, then we'll do it. Okay. Better. So, what we want to look at is where invoice number is null. Okay, okay, you can't say it is not equal to 0 or something like that. Null means no entry. Nothing's there. Okay. So we'll come back in here and we'll modify this. So I'm going to come back to my query. I'll say where invoice number, Number is no. Okay. I've got to use that type of expression. Okay. And then I'll order by vendor name. Just, give them to me in alphabetical order. Okay. And then order by.
Misspelled.
Yeah, I sure did, didn't I? Order by vendor name. Thank you. All right. Well, I'll do a little better job there. I just want the name. I don't want people to tell me I got the null in there. Better. Okay, there's the list of vendors who don't have any invoices. All 88. Yes.
Is the equal sign reserved for the values that have like numbers in them?
Right.
Okay.
Equality is between values. Okay, null doesn't mean a value. And I explained that the last time with a little bit. Okay, every little field has a little bit in there. It says, have you made an entry into that field yet? And that's what is null is doing. No entry is in there. It's all hidden from you. You don't get to tamper with that. You just go ahead and use it. Okay. Is that clear for everyone? Nice and handy. Yeah.
It says equal sign is null, but then I think you just say order by vendor name, so they will be fine.
No, they're not. What do you mean they?
How does it get rid of the ones that are null? You got rid of
I got rid of that because in this filtering here.
where?
Yeah, the where clause. Only show me the ones that had no's in this column here. These I don't want to see these. Okay. I just filtered out, I added these two to the result set. Okay. Questions? We'll have another way of doing that here shortly. That's probably the main reason for using outer joins. There's another. Doesn't matter with me. Okay. We're in good shape. right, so let's move on. Okay. I'd like to generate a report that shows that the invoice number, invoice total, and some indication as to whether the invoice is active or paid. Well, how will I know whether something is active or paid? Outstanding balance. So what I'd like to do is maybe, if it's got an outstanding balance, I might want to tag it with this thing called active. We'll figure out maybe how I might do that. And if it doesn't have, then you're all paid up. And then, so we could go down through the, one approach would be, just look, think, there's always many ways to do things. What I could do we've got our table of invoices here, invoices. Okay, so I could start, go down through each invoice, start with that one. And if you got an outstanding balance due, I might create a little table over here called the active table. And put the vendor name, something in there, the invoice, so forth. And also have a column, one of those constant columns. I create a constant column. And if they're paid up, we call that inactive. In fact, I might have an inactive column there. I could have two separate tables. Generally, this is referred to as an archive table to do that. Then if I wanted to show them together, I can glue them together. I call them gluing. And the glue number, or the glue operator is union. Basically, follow that table, or follow this table with this one. The only requirement is all the columns and the types have to match up. Okay. So let's look at the syntax for that, and then come back and revisit this. Okay, so a union operator is, I'll have it, basically, that's what we did. We select out all of those that have a balance due, and you put them in that table, or that query, and then we'll do this one here, we'll select all of those out that are all paid up. Okay, put them in that table. I don't have to store that table, I can just make that an intermediate table on the fly. Example. Okay, so what this does, this union operator does, is, okay, it's going to combine the result set of two or more select statements, or you can think of any result statement from a select, or any result from a select statement is really just an intermediate table. Later we'll look at how we save them. But we can use them on the fly. Each result must return the same number of columns, okay? So everything here has to match up down here. And the corresponding columns, as he said, have to have the same data type. So basically what I'm gonna do is I'm gonna stack one on top of the other. I'll end up with one total. Or one result. I could also save that. So looking at our problem. Okay. That first column, that's the way we create that constant. It's always going to put the word active in that first column. Okay. So I'm going to have active, and I call that the source. Invoice number, invoice total, and in here, okay, that's when we got a balance due. Union. Now select paid as a source, and here is the case where we're all paid up. And then just for grins, we'll go ahead and order those by invoice total. Okay, see what we're doing. Each one of those is really an intermediate table, just like this. And then we put them together, and then get the final table, which is the result set. Okay, let's take a look at that. And see what that outcome looks like. Oh, I don't know why I keep doing that. Let's just do this. Let's see. All right, okay, let me come back here. Control A, Control B. All right, let's all the way down. Okay. Let's see. Hey, look at that. Well, looks like I got good minus signs in there this time. Okay, excellent. Look at that. Oh, that's nice. Highest invoices to low. See who's paid up, where's that piece. Okay? And we did that with that union operator. Pardon? Somebody got a question? That's required. Clear?
Who's the AS?
As, what you're doing is you're creating that label. That's what you're doing. See, but I got a constant there up there. I want something at the, I want to, as source. I want a label right there at the top. That's what as. Okay, we're creating a label is what we're doing, but we're creating a label, and then we're creating the content in there as just one constant. It's just, not set of characters, just basically we're just tagging that says you're paid up or you're out.
Basically, it's a value.
Yeah, it's a value, but it's constant. It's just a tag. Clear? Not clear? All right. Let's muddy up the water. All right, so I'm going to do that. See what else we got. That. We'll get to that. Homework. Okay. Query problem. Oh, okay. This is probably a good one. We have employees who are also customers for our products. You better be a customer or else. Okay. I worked for Gulf Petroleum for 1 year. They caught you buying gas at Kerr McGee or Shamrock. Do your job. You're going to be loyal or else. Okay. All right. So we have employees who are also customers. These are voluntary customers. Okay. We would like to reward these employee customers with a gift card. Nice. For their loyalty to our products. So we'd like to write a query that displays a list of these employee customers. And what I need, I believe I need to do a little work in my server. And I think I need to add the example database. Okay, let's see. And you can get the examples database off of the I drive. And I already got it on the C drive. What am I looking for? Object Explorer. Excellent. Okay, so I'll have that there. If I go out on my C drive, let's see. Now, examples MDF, and I got the log. Good, that's what I wanted to see, if I got that. So I gotta have that in place. So I'm gonna come up here, and I'm gonna attach. Attach. And I'm going to go out here and see if I can find that. There it is, examples. And then I'm going to say OK. And I'm going to say OK. And now I've got examples. And now I need to look in here to make sure I got an employee, yeah, customers, and employees. Excellent. All right, so I've got what I need. And I'm going to close that there. Okay. So I'm going to come back here, and go back here and analyze my problem before we start looking at some concepts and just banging away. Let's see conceptually what we want to do. Okay, so I've got customers. Okay. I've got customers. And I've got employees. Employees. Got customers. What do I need to do to find the customers or the employees who are customers? Gotta do something to connect them. Need a common column with them. Okay. Now this example database is all puttied up, but we're going to do it now. Let's go out and do a little diagram just for practice doing diagrams again. So what I'm going to do is I'm going to go out here, and I'm going to back here to the Object Explorer, and I'm going to, see, I got a whole bunch of stuff. It's a conglomeration. So this is not a normal database. Okay? So I'm going to do a database diagram on examples. New diagram. But I'm only going to do it for employees and customers. So I can get a view, okay, of this. So I'm going to add these. Okay, and I'm going to do that. Okay, now, they are not, there's no connection between them, but now I got a nice picture here of looking and saying, is there any columns that might be common? Yeah, we're not going to have any IDs, are we? Because they're just totally disconnected. So we're going to have to go with at least we probably better do last name and first name, hadn't we?
Mhm.
Yeah.
Yeah, because there's a lot of Smiths. Okay? And Thomases, and you know, a whole bunch of them, okay? So that would be our best candidate to get a match. So now we're doing joins based on common columns. They're just doing the good old plain math like join here, okay? All right, so we can conceptually see how we're going to do this, and so let's look at a solution, and this is using the table join. Yes.
Does the number of characters in the column represent a problem?
It shouldn't, because we're going to hopefully these are going to be variable characters format, so it's all compressed. The difference here is what she's asking. That's a good observation. If I stored name say in fixed, that's character format, I might have Smith, and I got spaces in here. They're padded. I have to, in my string, I have to include that exact number of spaces to get a match. Ugly. If it's variable character, Smith, no spaces. That's what you want. And you would never store the only time you use a fixed field format is when you're going to fill them all up, like a product number. You know, we got a standard product number. It's got A, B, C, and 1, 2, 3. Okay. Or like a Social Security number, or a CWID, something that's always going to fill it up, but never something like that. So it's going to be variable character. So we're not going to have a problem with that. Okay. All right. So this is our candidate. Okay. First name, last name, employees, join customer on last name and first name. Okay, we're going to do it this way first. Okay, we got another solution, but let's get a good feel for this. I never seem to get smart. Okay, and so I'm going to go up here, and then I'm going to do the query. Where's the query? Okay, let's do a query. And control. Okay. Oh, I don't like those things. Okay, I just get that out of there. Oh, it doesn't like my single quotes there. Because I need a space in there. Yeah, I just want a space in there, so first name, last name. So I'll just put my own. Okay, now I'm okay. All right. And we'll execute. Okay, looks like we got one loyal customer. Okay, one employee buying our stuff. Check this out. Okay, these are small.
Yeah.
These are small tables. Okay. All right. So, okay. All of that work just to get one made. Okay. Everybody follow what we did here? All right. We got another technique. And that is the intersect. Okay, now we're getting into this. Anybody here have to take linear algebra? You've already had math, and you've already got a college degree in linear algebra.
I took it a couple of years ago.
Yeah, that's set theory, all of that's fun. Oh, yeah, it's great stuff. Okay, well, we're back to that, and this kind of starts to make sense now, okay? So what we can think of is I got a blob here. I don't use the big circle. I got the blob of employees. And I got the blob of customers. But I'm going to make the kind of intersect there a little bit. This is the customers. And this blob in here is our loyal employees who are buying our stuff. I mean, not just one. Huh?
This being one employee.
One employee. Okay, this is our good employees here, and we're going to give them a gift card. And now we're going to replace that other thing that we had with the intersect word. Okay. It includes rows that are in both queries. Yeah, we don't have to worry about any joins or anything. Okay, so now we'll go to this. All right. Wow. Does it get any better than that? All right, so now we're going to come back here. There you go. Control A, Control B. All right. And then we're going to see if we get the same outcome. And sure enough, Thomas Hardy. Okay. Okay.
Preferred, if you're getting the same,
This would make it easier.
yeah.
Yeah, it should. Yeah, it's a lot easier because I had to go and kind of look at the join condition on it. This one here, you know, this is what's referred to as set arithmetic, set algebra. That's what your relational database and all the query stuff is really based on. That was actually embedded or contrived by a mathematician, Edgar Todd, I think he did. Probably had this in your book. Okay. IBM. Way back, too far way back, 270s. Okay. So that's a nice one. So occasionally you can take advantage of that. That's probably not going to be your standard stuff. It's always going to be select, from, join, where. Be living with that stuff. Okay, let's see what else we got. Yeah, I think I'm running out of fun things to do here. Oh, we want to have a promotional contest for our customers. However, our employees who are also customers, okay, this guy's not going to be allowed to play, allowed to participate in the contest, because that's, that was too legitimate. Write a query listing all of our customers who are not an employee. Gee, that sounds familiar, doesn't it?
Not intersect.
We just didn't do that with outer join too, couldn't we? But we don't want to do that anymore.
Could you just write an exception statement?
Exception? That's called an error in our programming language. You want the except operator. Just reading ahead. All right. Excludes rows from the first query if they're also in the second query. Okay, so we've got, okay, so what we want to do is, we're interested in our customers, aren't we? Okay, So we've got this little customer in here, okay? So what we gotta do is we gotta, no, you don't get to play, and then we're gonna take a bite out of the apple. That's what we want to do. Okay. And we do that with the accept. So it excludes all rows from the first query that I have up there, which is going to be an employee, if they also occur in the second query. Okay. All right. Sorry. That's customers. I had it backwards. I had my diagram backwards. All right. So let's and let's see. Okay. And we'll come down here. And, all right. So now we're going to get all the customers except Mr. Hardy. Okay. So here's all our, we got 23 customers. All right, so you can see that he's non-conspicuously missing. Okay, he's not in there. We took him out because he's an employee. Okay. Okay. I don't think that, what else have I got? Revisit the problem. Okay? In other words, this is just a review now. Okay. Going back to the vendors who don't have invoices, you could do that, couldn't you? Use the accept as opposed to out of show. So that's always the best option. Okay, any questions? Okay. Everything clear? Sort of clear?
Yes.
Yes.
Yes. Those are enthusiastic responses. Okay. Okay. Program 2. Riverbend database. That's not right. Okay. Okay. Got. Three table join queries for next week. Okay. Be sure to print yourself that diagram for that river bend, because that's really going to help you now. That's a big database relative to. If you didn't find it there, it's not. I'll put this out there. I think everything else is out there, I believe. So, uh, what? Get it in the wrong place. Paste. There it is. Okay. Out there on the iDrive. And that's all I got. If you want to stay here and work, that's fine. I'll be in the office if you have any questions. On your way.
Run out of paper, so.
I don't have a river band here, but I'll do it. Okay. So let's suppose I'm going to do another one here on examples. Okay, so I got database diagrams, and I'm going to do, so you right click on that, new database diagram. Okay. And then you get a dialog box come up, and I might want something, I may want something like
Customers and
employees and departments. I think those may go together. Okay. I just want to do those two. Okay. So I add those, as soon as I do that, it creates it, and I close that. So here I have a department name, and there's department number, so those are related.
Okay, we just have to see what columns are related in both the
Yeah.
tables.
So you don't actually want us to create the relationship in the foreign key?
No.
You just want us to put the tables up there so we can see?
Right.
Okay.
Now, in the case of Riverbend, you should have the relationship should already be in there. Is that your question?
Yeah, there's no.
There's no diagram on the riverbed. I look.
Well, you have to create it.
He wants us to make it.
Okay.
I'll do it right here.
Okay.
Yes. Okay. Okay, I'll do the riverbed.
Like for the AP database, we had everything connected.
Right.
Can't we do like that? Do you think?
But here, this one doesn't have a connection there because it doesn't have a constraints in there, so I wasn't expecting that. So I'm going to do the riverbed now. So I got to go out to the iDrive, and I got to go find the riverbed script. Okay. And I'm going to do that. And I'm going to take, create riverbed database. I'm going to copy that. I'm going to put that on my desktop. Paste. Okay. I already had one. Cancel. All right, so I already have. Okay. Okay. you don't have a database for the Riverbend, so what you got to do is create it and then run the script, which creates the tables and adds all the records. So I'm going to go out here now and go to databases, close that up. Okay. Okay. New database.
Yeah, I got that.
Okay. And I'm going to type in Riverbend, so I'm going to create the database.
I've done that.
R-I-V-E-R.
I think it's a small piece. I mean, like, do you want?
Oh, I don't, it doesn't make any difference.
Okay.
I'm just going to, it won't make any difference. Theirs might be that way.
Okay.
I'm going to say okay. Okay, so I got, okay, so I got a actual instance of SQL Server there, what I have. Now what I want to do is, but it doesn't have any tables in it.
Right.
Okay, so now I'm going to go out here, go to the desktop, I'm going to bring in that script, and there it is.
How do you know the difference between script and a database?
The difference is that when you have a database, you have an MDF file.
Okay. Yeah, the two files which
Right.
come for
And that's an
AT.
existing database. I don't have that here. All I got's a script, so I have to create this every time. On your machine at home, you have to do it once. Okay. So now I execute this. Make sure I got it in the Riverbend. I'll execute it. Okay, I've got it.
Do you have to use the word use in there?
That just covers my tail end. If I didn't do this up here. Let's see, I didn't do that. That was bad. I should have that use word in there. All right, so I'm going to close that. I don't need that anymore. And now I'm going to come back here to view Object Explorer. Riverbend. Database diagram. Okay, I'm gonna right click. I want a new database diagram. Okay, it says you don't have one. Thank you. Make one. Okay, I want them all. Okay, and then I'm going to say add. Close. And I'm going to do that. Okay, now you see all the connectivity?
Yes.
Okay. That's going to be real handy for table joins in this one.
Yeah, it is, thank you.
Yeah.
Okay?
Thank you, sir.
Thank you.
Because without it, it's going to be pretty tough. Okay. Get used to those database diagrams. They'll save you.